is a walkthrough of Problem 1 on Practice Exam 2 of Module 8 in the book Problem Solving Guide for Mechanics and Thermodynamics. A wooden lathe is spinning when the power is shut off. It spins through 100 revolutions as it uniformly comes to a stop in 5 seconds. Part A asks for the initial revolution frequency in RPM before it was shut off. How fast was it going when it was shut off? What was the initial omega? Part B, what's the angular acceleration during the 5 seconds it takes to stop? Let's think. Starts at some omega initial, slows uniformly to 0 in 5 seconds. During the 5 seconds, it makes 100 revolutions. What can we do with that? Okay, it looks like the average angular speed has to be 20 revolutions per second. It goes 100 revolutions in 5 seconds. The average has to be 20 revolutions per second. It ends up at 0. If it ends up at 0 and the average is 20 revolutions per second, the starting must have been 40 revolutions per second. So we have part A, 40 revolutions per second. But it has 40 revolutions per minute. 40 revolutions every second. It goes around 40 times. If it goes around 40 times every second, it has to go around multiplied by 60, 2,400. 2,400 revolutions a minute. So the answer to part A is 2,400 RPM. Part B, what's the angular acceleration during the 5 seconds? Starts off at 40 revolutions per second and it stops in 5 seconds. How much does it slow down each second? It's got to be 8. 8 revolutions per second each second. So I like to write it like this, minus 8 revolutions per second each second. Conventionally, it's written like this, but the problem is second squared is very non-intuitive. So it slows down by 8 revolutions per second every second. Starts off at 40 revolutions per second. After 1 second, it's going 32 revolutions per second, 8 revolutions per second slower. Then 24 revolutions per second, 16 revolutions per second, 8 revolutions per second, and finally, after 5 seconds, it's at rest. Easy peasy. That's problem 1.